Okay, dimensional analysis. So in physics, dimension really just means like the unit. So in dimensional analysis, we're focusing on the units of an equation. So let's say I had 2 meters equals 5 meters. Now we know, of course, 2 meters does not equal 5 meters. But what we really only care about is if the units are the same. So we both have meters on one side, on both sides. So the equation might not be numerically correct, but it's dimensionally correct. Let's say we have velocity equals distance over time. So with velocity, you might think, well, there's a v over here, but there's not a v over here. Well, you have to actually know what velocity means. And velocity, you wouldn't say you just ran 5 velocities, or when you ran 5 velocities. Velocity actually equals distance over time. So if you have, let's say, 5 meters per second equals 10 meters per 2 seconds. This is correct numerically and dimensionally. Why? Because we have meters and seconds and meters and seconds. So, I'm trying to think of an example. Let's say we had we have okay, so we have velocity equals 2 pi r over time. So 2 pi r is actually the equation for the circumference of the circle. So really, what we're describing here is how fast you go around the circle, but that doesn't really matter, it's just context. So remember, velocity deals with a distance unit and a time unit. And we have the time unit on one side. Now 2 pi r. So 2 is unitless, it's just a number. Pi is also unitless, it's just a number. R, what would we measure the radius with? We would measure it with distance or length. So really, we have, if we were to actually measure it, we would have like meters and seconds. And so our units would be the same on both sides. So let's clear the screen. So in the homework, it asked if an equation is dimensionally correct, does that mean it's correct? So what's that really saying is, if we have the same units on both sides, does that make it correct? Well, in this case, 2 meters does equal 2 meters. And we also have meters on both sides. Well, let's look at another case. 5 seconds and 2 seconds. Now, our equation is dimensionally correct. We have the same units on both sides, but it is not numerically correct. 5 seconds does not equal 2 seconds. So the answer to that question would be no. Just because an equation is dimensionally correct does not mean that it is correct. And one other quick note is when dealing with dimensions, powers is important. If we have 5 seconds squared equals 5 seconds, you might think, well, I have a seconds here and I have a seconds here. But that's actually not true. You see, if we're squaring the 5, that would be different. But we're not squaring the 5, we're actually squaring the seconds. So really, if we expand this, it's like 5 times seconds, because we're squaring the seconds equals 5 seconds. This is not dimensionally correct because we have squared seconds squared, but we only have seconds on this side. And so if I asked you, I think, so in the homework okay, so in the homework it had t equals, I don't remember the exact numbers, but it was like 2 pi times the square root of length over gravitational acceleration. So let's focus on our units. What would you measure time in? You would measure it in seconds. Okay, 2 is unitless, just a number. Pi is unitless, just a number. Okay, now let's focus on L. L stands for length. What would we measure length in? We would measure it in meters. I mean, you could measure it in like feet or inches, but here we're measuring it in meters. What would you measure gravitational acceleration? Well, acceleration is length per time squared. That's an L. So what would we measure length in? We would measure it in meters. What would we measure time in? Seconds. Seconds squared. And remember, we could be measuring time in minutes, we could be measuring time in hours, but it's just a unit for time that we can use. So let's simplify this part. So we have s equals the square root, and remember, when dividing by another fraction, it's opposite, not opposite. It's just multiplying the reciprocal. So we have m over 1 times, m was on the top, now it's going to be on the bottom. Now s squared is going to be on the top. So our m's actually cancel out here, leaving us with s equals the square root of s squared. Well, if you remember, anything, so if I have the square root of 5 squared, that's going to be 5. If I have the square root of 6 squared, that's going to be 6. So the square root of s squared is s. So we end up with s equals s. And through our work, we show that this equation is dimensionally correct. Remember, we didn't care about the actual values of length or the actual values of the gravitational force or the actual values of time. We cared about the units. So that's why we could get rid of 2 and pi. They're unitless. And I hope that makes sense for dimensional analysis.